Hi, I'm Manuel Pardo Jr. I'm working with Dell EMC as a data center designer under the Data Center Managed Services project. My work site is in the Kingdom of Saudi Arabia. I'm fun with working with technology and have been given an opportunity to work with one of the biggest technology-driven industry here in ASA. My role as a data center designer is to handle all the implementation within the data center, whether it might be a server or a network infrastructure or a data center support infrastructure like the power and cooling. Today, I'm going to discuss one of the implementation that I have encountered working on the job site, and that is the implementation of DWDM. For the purpose of this presentation, I will provide a brief introduction and uh, brief terminologies that involves DWDM and fiber optics. In a data or a packet network technology, we usually look into the premise of the network coming from our normal office network or our data center, which involves switches and routers, and then the servers provide their network as a big cloud. Typically, we talk about the logical connectivity of our switches or and routers, but the underlying physical network is an abstract layer for our service provider, and one often requires to know if the router has a 10G, 4G, or 100G interface, and how many interfaces are available in the exceptions depending on the applications we are discussing. But again, as a network technician or an engineer, these factors are what matters. But in the optical transmission layer, we deeply discuss the transport mechanism and even the exact distance in which our devices are located and how they are distant with each other. Also, we need to know the underlying devices being connected. With that said, I'm going to discuss some of the basic components on what is an optical network and the building blocks that comprise the DWDM system. So, what is fiber optic? Fiber optic refers to the technology of transmitting light down the, in a thin strand of highly transparent material, usually glass, but sometimes plastic. Fiber optics is used in communication, lighting, medicine, optical inspection, or even to make sensors. There are two types of fiber that is being used in a data communication. One is the single mode fiber, and the other one is a multi-mode fiber. But typically in a DWDM system, all fibers that is being used is a single mode fiber. One of the characteristics when we're transferring energy from one part to the other is what we call an effect of attenuation. So an attenuation is a reduction in optical power as it passes along a fiber, usually expressed in decibels. For fibers, we talk about attenuation coefficient or the attenuation per unit length, or what we usually use as the unit of dB per kilometer. There are also different types of attenuation, which I will discuss briefly here. You have absorptions. The absorption is caused by absorbing the light that passes and then it converts by heat by molecules in the glass. And the other one is scattering. Scattering occurs when light collides with individual atoms due to some impurities of the glass or anisotropic. So now that we have some information about fibers and its characteristics, let me draw your attention in the DWDM technology. Today, the network usage is growing exponentially with the need of faster data delivery and the need of higher bandwidth with a consistency of quality of service with a lower cost. And to resolve such a demand, there are solutions that are prevalent today, and one of which is the increase of, or by increasing the channel or channel capacity, or one of which is using DWDM. So, what is WDM? DWDM, or dense wavelength division multiplexing, is an optical multiplexing technology used to increase bandwidth over existing fiber networks. DWDM works by combining and transmitting multiple signals simultaneously at different wavelengths on the same fiber. There are components of the DWDM system, generally consists with five. One is optical transmitters or receivers, DWDM MUX, DMUX filters, and optical add-drop multiplexers, or OADM or ODM. Then we have optical amplifiers, then transponders or wavelength converters. So what is a transmitter or receiver? A transmitter are described as a DWDM component since they provide the source signal which are then multiplexed. It is a reverse for receiving. They are receiving the signals as a receiver. So next is the DWDM MUX, DMUX filters. So this is a device or a component which multiple wavelengths created by the multiple transmitters and operating on a different fibers are combined into one fiber by way of an optical filter or MUX filter. Next component is optical add-drop multiplexers. So optical add-drop multiplexers have a different functions compared with MUX DMUX filters. Here in a figure, in the figure that shows the operation of a one-channel ODM or OADM. This ODM is designed to only add or drop signal, drop optical signal with a particular wavelength. From the left, an incoming composite signal is broken into two components, drop and pass-through. The ODM drops only the red optical signal stream, and then the drop signal stream is passed to the receiver of a client device. The remaining optical signals that pass through an ODM are multiplexed with a new wavelength, added signal stream. The ODM adds the new red optical signal stream, which operates at the same length or wavelength as the drop signal. The new optical signal stream is combined with the pass-through signals to form a new composite signal. Another component is the optical amplifiers. Optical amplifiers boost the amplitude or add gain to optical signals passing on a fiber by directly stimulating the photons of the signal with extra energy. They are in-fiber devices, so optical amplifiers amplify optical signals across a broad range of wavelengths. This is very important in the DWDM system application. Erbium doped fiber amplifiers, or EDFAs, are commonly used type of in-fiber optical amplifiers. Another component is a transponder or a wavelength converter. They convert the optical signals from one incoming wavelength to another outgoing wavelength, suitable for DWDM applications. Transponders are somewhat called optical wavelength converters. A converter, or a transponder rather, performs an OEO operation to convert wavelengths of light. Thus, some people call them from OEO for short. Within the DWDM system, a transponder converts the client optical signal to an electrical signal and then performs either 2R, or what you call re-amplify and reshape, or 3R, re-amplify, reshape, and retiming function. The figure below shows a bidirectional transponder operation. The transponder is located between the client device and the DWDM system. From left to right, the transponder converts the operating wavelength of the incoming bit stream to an ITU compliant wavelength. It, it transmits its output in a DWDM system. On the receive side, or from right to left, the process is reversed. The transponder receives an ITU compliant bitstream and convert the signals back to the wavelength used by the client device. Now that we know that there are these components of the DWDM, we might ask, how do they do work? So usually the transponder accepts inputs in the form of standard single mode or a laser pulse. The input can come from different physical media and different protocols and traffic types. The wavelength of the transponder input signal is mapped to the DWDM wavelength. Then the DWDM wavelength from the transponder are multiplexed with signals from the direct interface to form a composite optical signal which is launched into the fiber. A pulse amplifier or a booster amplifier boosts the strength of the optical signal as it leaves the multiplexer. An OADM or ODM is used at a remote location to drop and add bit stream to a specific wavelength. Then additional optical amplifier can be used along the fiber span as needed. A preamplifier boosts the signal before it enters the demultiplexers. The incoming signal is demultiplexed into individual DWDM wavelengths. The individual DWDM lambdas or wavelength are either mapped to the required output type through the transponder or they are passed directly to the client side equipment. Using DWDM system, using DWDM technology, DWDM system provide the bandwidth for large amount of data. In fact, the higher capacity of DWDM system is growing as technology advances that allow closer spacing and therefore higher number of wavelengths. But DWDM is also moving beyond transport to become the basis of all optical networking with wavelengths provisioning and mesh-based protection. Switching at the photonic layer will enable this evolution, as will the routing protocols that allows light paths to traverse the network in much the same way as the virtual circuits do today. With the development of technologies, DW systems may need more advanced components to exert greater advantages. In this project, we deployed an Alcatel 1830 PSS 36 and 64 devices. We use project management framework to successfully implement the project, coming from the initiation conducted by transmission group, planning, execution, monitoring and controlling, then closure. From its initiation phase, where they created their project charter, they worked through the planning phase. My role as my role as part of the data center management is to provide them the location where they need to install their equipment based on their requirements. The 1830 PSS Alcatel Lucent equipment requires DC power in addition. In addition, they will serve as an OTN pass-through link for Alcobar and Lasilki. With that requirements, I provided the most suited room, which is our telco room, because it serves as a conduit of all external network or external route of data. You can think of it as a bridge that connects your internal and external network infrastructure. During the execution phase, our group is responsible on monitoring, supervising the activities that their vendor will do inside the data center. We ensure that they adhere to the DCM policies and the standard as a control and monitoring activities. all activities are based from the hosting agreement that was